So we're going to start part three of this class. And let me just contrast that with your previous parts. So when we did part one of the class, which basically was test one, we worked with first order differential equations. What does that mean? First order, first derivative. Everybody else, if you were to throw it onto the right-hand side, we could write it like this. And we had a lot of them, right? So we had, for instance, explicit. Remember? Explicit was when you had the right-hand side pure t. So pure independent variable. We also had linear, right? And linear is dy dt. And if we go ahead and put it into normal form, we could have, if this is equal to 0, then it's homogeneous. And it was not equal to 0, it's non-homogeneous, right? We also had separable, right? So that was dy dt equal f of t g of y. And we also had autonomous, which is a kind of separable, right? But the whole point, let's see, here we go, right-hand side pure y. And then we also had exact, right? So let's see, how did we write it? F, let's see, we used m, right? M of xy dx plus n of xy dy equals 0, and partial of m with respect to y equal partial of n with respect to x, right? And then we also had make it exact, right? So use integrating factor to make exact. Okay, so that was part one. All right. And then we had part two. And part two was higher order. But was higher order linear. So you can see with part one, it wasn't necessarily linear, right? Linear was just one type. Now with linear, that's when you put it into normal form. It could be homogeneous or non-homogeneous. But in part two, it was always linear and higher order. So we essentially had L of t y equals 0, homogeneous, L of t y equal f of t. Okay. And so today what we want to do is we're moving into part three. So part three, we finally hit systems. And when we do systems, we're only going to do first order systems. Okay, of ordinary differential equations. And it turns out that if you have higher order, you can recast it into first order. Okay, so that's why we just need to do first order. So let's do an example. So first order, how about this? We have something like this. We've all seen this before. So here's spring mass system with damping. Let's make it homogeneous, no external driving force. And when you have this, you have your initial conditions, right? So you have position at time 0, and because it's second order, then you need one more. So this is going to be this. So I'm going to go ahead and we can call this velocity, right? All right. So whenever you have, this is linear and it's second order. And let's go ahead and put it into normal form. Okay, I'll write it again. Second order, and it happens to be linear. And it's one equation. And what we're going to do is we're going to practice rewriting it or recasting it into a first order system. And it turns out we're going to call it dimension n equal 2. And the 2 is just this and this. Okay, so let's see how this works. So go ahead and write dy dt. And what we're going to do, we know that that is velocity. So I'm going to call this v. And then when you take the derivative of velocity, that's the second derivative. And so the second derivative is actually this. So does everybody see that this and this are the same? And if that's the case, then you can take all of this and move it over to this side. And we'll go ahead and write it this way. So notice it's minus k over m, and then you have y minus lambda over m, and then the second derivative, the first derivative, dy dt. But instead of writing this, I'm going to erase it, and notice what this is. That's the v. So instead of writing this, I'm going to write this. And now what we have is we can write this and line up the v. And notice that is the same thing as 0y plus 1v. Let me make that nicer. Okay, there we go. And does everybody see that we could write it like so? We could say this is the derivative with respect to t of y and v is equal to, and now I'm going to go ahead, I'm going to make it all this blue. And what we have is we have 0, 1, minus k over m, minus gamma over m. And then look, now we go ahead and make the y black. So this is going to be y and v. And notice what this is, right? It's this times this, right? So it's when you go row column, this times this times this. That's the 1v. And it's equal to the derivative of that. And then you have row column, which is this times this plus this times this equal the derivative of that, which is this. And so look, what we did is now we can have a little dictionary off to the side. And what we will say is this y is going to be equal to yv. And remember, whenever you have dependent variable, actually, it's a function. So if I could write it this way, this is fine. But remember, implicitly, that really means y of t. And remember, this really means this, right? Does everybody see that? So we can leave off the t, and that's fine, or we can put it on. Okay, so either way is fine. But there you go, that's your dictionary. And so does everybody now see what we have over here? What we have is, this is d dt of y equal, and then you could label this as a y. And look at this. This looks a lot like this, right? We have dy dt plus a of t y equals 0. This is your linear first order. And what we want is we're going to make things look like things from part 1. So what you will see, though, it's bold. So this looks like, it's just that the A is on the right-hand side. This looks like something from part 1. But what you need to do is you need to, when you see the bottom one, you need to imagine this. And then you need to imagine this. Okay? So, because it's linear, anytime anything's linear, you can write it in matrix form. But if it is not linear, then you would have to then you would just write it in this form. And let me just talk a little bit more about this one. So suppose we weren't interested in writing in matrix form. Then what you could do is, you see how this works? The first equation is a function of t, y, and v. Okay? And the second equation, I'm going to call this a function, is another function of t, y, and v. Okay? So in other words, this is this one, and this is this one. Okay? And what you would do is, again, as part of your dictionary, what it is f, and now look, of t, y. Can you see when you have this bold y, that's actually y and v. That is equal to f1 of t, y, and v. You can write this as this if you wanted to. f2, t, y, and v. So remember the y and the v, this is this whole thing. So does everybody see this is actually this guy right there? This is actually this guy. Okay? So you can write it out or leave it like so. So when you write it this way, what you have is in vector form. So this is over here, this is the matrix form. And you can do the matrix form when it's linear. If it's not linear, you can't. So then here, this is the derivative. You see the y and the v. This y has a y and a v. So that's this right here. And then that is equal to f of t, y. And remember, this is y and v. So do you see what we've got? So this over here now can be written in terms of vector form, like so. And when you write it this way, doesn't this look like this? So this is your general first order equation, but that's just one equation. So when you see it bold and with a hat on top of it, when you look at this, you need to imagine this. And in this particular case, it was actually this. Okay? So when you see the bold, you want to remember that this is shorthand, and we're writing it so that it looks like something from part 1, but you have to imagine all the other things above it. Okay? So now let's go ahead and write down the initial condition. So you see we have the y, and we also have the v, right? So we can see that this is going to be y. Let me write it dark. So this is y. of 0, right? And that's going to be y naught and v naught, right? Because we have this. Okay. So this is your initial condition. All right. So there you go. Okay. So, and actually what you could also say is you could say, let, as part of your dictionary, you could say y naught is going to be this. So you could actually, writing it this way, what you could do is you could even go like this, right? Then it really looks like it's something from part 1. Okay. All right. So let's do another example. Okay. So I'm going to write down this one. So we have the third derivative plus p times the second derivative plus q times the first derivative plus ry equals 0. And notice this is third order. It happens to be linear differential equation. And what we want to do is we want to write it as a system. So we recast it as a first order system. And what we say it's going to be dimension n equal 3. And where did the 3 come from? Third order, third derivative. Okay. Now, let's go ahead and look at this. So what you do is you say, well, you're always going to have first derivatives because it's first order. So if you can look at this and you can say, let that be v. Let the derivative of v be w. So that would be velocity, and derivative of velocity is acceleration, and the derivative of acceleration is jerk. But this is the second derivative, and this is the third derivative. And what is the third derivative? The third derivative is this. And so what you do is you take all of this and move it to the side. Now, notice the order. Minus ry minus q dy dt minus p second derivative. But remember, we want to use these variables. So this is going to be minus qv minus p. The second derivative is this, right? Minus w. Okay? So this over here downstairs, this is scratch work, and you need to get rid of it. So use that to help you. And now let's go ahead. So can everybody see what we're doing? Here's a dictionary. And you should write down your dictionary. And so what you have is you're going to have y. And it's going to be equal to y v w. And this is going to be equal to, this is the y. This is the second derivative, the first derivative. And this is the second derivative, right? So what I'll do is, how about I just go like this? Y prime, y double prime. Okay, so that's our dictionary. And now let's go ahead. Having finished this part, let's write it. We know it's linear, so we can write it as a matrix. So we'll go ahead and put the V over here, put the W over here. And does everybody see that what we have is 0, Y, this is a 1, and then this is 0, W, 0, Y, 0, V, this is 1, W. And notice this is minus R, minus Q, minus P. And so, since you've lined this all up, Does everybody see? Now I'm going to go like this. So when you have a system, you often draw, you keep that there so everybody sees that it's a system. And notice what you have. You're going to take the derivative of y, v, and w, right? And that's going to be equal to 0, 1, 0, 0, 0, 1 minus r minus q minus p. And this is y, v, w. And there you go. And look at this. This is actually the derivative of y. Label that matrix as an A, y. Does everybody see that this looks just like this? Except that, if we had written it like this, like that, right? It's just that, last time we'd like to put the A on the left-hand side, but you can tell that this, is linear, okay? So what we're trying to do is now, when we do it from, part 1, we don't want it bold. So it's like this, right? But here, every time you see bold, so actually this should not be bold, right? So these guys right here don't need to be bold because, right, this doesn't need to be bold. But it's nice. I mean, I just wrote it bold just so that you could see. So when you see bold, right, here I can write the whole thing and make it not bold. Then what you want to remember is that, not bold, is not vector. And then when it's bold, it's a matrix or a vector. Okay. Now, this is the linear, this is writing it, whenever it's a first order, third order, that. I'm just not saying it right. Whenever you have a linear equation, you can turn it, this is, you can always write it in matrix form when you have it as a system. But if it were not a system, right, then we've got that dictionary. And then over here, you would write dy dt equal f of ty, right? And the y is this is yvw, right? And you want to keep in mind that this f over here of ty is equal to f1 of tyvw, f2 tyvw, f3 tyvw. So you see, it's very nice not to write this out so many times and to write it like this. And remember who each one is. So this one was the 1v. That one was this one. So, that was this one. And this is this one. And this over here is this one, right? Now, actually, we don't need to have this 0. We don't need to have this 0. We don't need this. We don't need this. We don't need this, right? So you can go ahead and just write it like this if we're not going to put it into matrix form. Okay? Right. And looking at it like this, remember, again, we're trying to make things look like they're from part 1. But when you see the bold, what do you need to do? Well, when you see this, you need to imagine this, and then you need to imagine this. Okay? Similarly, if you see this, you need to imagine this. Okay? All right. So let's do it in sort of more generally. Okay? So in this section, let's write everything with X's instead of Y's. All right. So what we're going to have is we're going to have, say, for instance, and I'll do n equal 3. Okay. So what we're going to have is we're going to have x, right? And who's x? X is going to be x1, x2, x3. And it can go up higher, x4, x5, xn. All right. And also, these are what you're going to be solving for. So even though I just write x, remember this is actually x of t, right? And so I might leave off the of t, but you would know that this is actually x1 of t, x2 of t, x3 of t, right? So we can leave that off or write it out. Okay, but if I leave it off, you need to know that's there. Then when you write your system, right, these are all going to be first order. So I would recommend to you that you always write the first derivative first, because when people are writing this down, they usually try to write the whole thing for this one, and by the end, when they finish, they're so exhausted that they forget that it was an entire system, and they just write one equation. So if you write all three down first, then you won't forget, and you know, oh wait, I've got to do all three of them. Okay. And just remember, here you're going to have t, x1, x2, x3. This is t, x1, x2, x3. Here's another function, f3 of t, x1, x2, x3. Okay, so this is going to be your first order system. First order, first derivative, right? First order, the highest order derivative, that's what this is. First order, first derivative, and it's going to be system, and it's going to be dimension, n equal 3. Okay? All right. And now when you write your initial conditions, right? What you have is you have x, and then you're going to say x1 of ti, x2 of ti, x3 ti, okay? And you would write this as x1i, x2i, x3i. And these right here are your this, and this. These are your initial data. And of course, this is your initial time. Okay, so this is writing out the first order system. Let's practice writing it in vector form. Okay, it might not be linear, in which case you would just, write it as we are doing right now. But if it is linear, you would write it in matrix form. Okay, so when you have matrices, you always know it's linear. In fact, linear algebra, if you look at the college catalog title of that course, it's called matrix algebra in different schools. So some schools call it matrix algebra, some schools call it linear algebra. So when you see matrices, you know it's linear. Okay, so looking at this, right? So everybody can see that this is going to be the derivative of your x, right? Everybody can see that. It's because the x is x1, x2, x3. And then this is equal to f of tx, right? And f of tx is equal to one more time, f1, t, x1, x2, x3, and you could just write it also as tx, but inside I think I'm just going to avoid vector form. So the whole thing is like this, and so you can see we've got this, right? And now what we have is, let's write down the initial condition. So let's go ahead. So your initial condition is going to be x of ti, right? And what it is it's going to be this. And this, I'm going to go off to the side. And there's more right here. Xi is going to be this. So we'll put the initial data here. And this is going to be x1i, x2i, x3i. So then this is going to be, so instead of writing it like that, I'll just go ahead and say this is going to be xi. Okay. So this is called your initial vector, or you would call it the vector of initial data. So that's why you just call it initial vector. Okay, so there you go. This is the vector form. So you see how this is so much, this looks just like something from part one, right? So we are going to write it with the x's. So please stick with x, okay? Sometimes we use s like for salt or something like that. So let me just say, remember way back when we had this y of ti equal yi, that was your initial value problem, right? And now what you have is you have this. It looks just like that. This is your initial value problem. And when you have this, when you see all the bold, all right, you need to imagine this. You need to imagine this, okay? So when you see the bold, imagine the one on top. So let's go ahead and do another example. So I'm going to write down this problem. I'll write it down here, y triple prime plus y prime plus e to the t y square equal cosine 3t. Okay, and this is going to have y of 0 equal 2, y prime of 0 equal -1, and y double prime of 0 equal 3. Or how about 5? That sounds good. Okay, so what I want you to do is you look at this. This is a third order equation, right? Third order, third derivative, third order equation. Is it linear? Can somebody say yes or no? Is it linear?
No. No.
No, because this and this, right? So not linear, so you're not going to be able to write it in matrix form. But let's write it as a first order system. So we're going to recast it as a first order system. What dimension is it going to be?
3.
Yes, because third order, third derivative, and equal 3. Okay? So I want you guys now to start doing that and write it with the x's. Please do everything in terms of x's, okay? And why don't you do a dictionary? So write down your dictionary. I'm going to be quiet. And then I'll give you a few seconds to do this. And I'll just wait. Okay. So with this, so we're going to write it with in terms of x's, right? And then this is going to be x1, x2, x3, because it's third order, right? Or dimension 3. And then over here, you would say y prime, y double prime, right? You always just go in order like that. And then you say to yourself, okay, I'm going to write down all the first derivatives like so, so I don't forget. And what happens is everybody just wants to go one at a time because they're very complete. You don't want to be like that. Write all of these down first, because when people do this first one, they get exhausted and they forget about the other two. Okay? So write it like this. Okay. Now what we're going to do is, let's write this out. So can somebody tell me what, in terms of x's, is the first derivative of x1? So you go to your dictionary. What is the first derivative of x1 in terms of x? What's the first derivative? When you take the derivative, it's going to be what? Y prime. And what is y prime equal to? What is the derivative of x1 in terms of x?
X2.
Exactly. Perfect. And now let's go to the next one. What is the derivative of x2? And go to your dictionary. Here's x2. Let's say you take the derivative. What are you going to get?
X3.
Exactly. Great. X3. Okay. And now, third derivative, you're going to look at this. And so x3. So look at x3 right here. Take the derivative. And what is the derivative of x3? Can somebody tell me what that is? Let me make it neater. What is the derivative of x3? It's y triple prime, right? And when you take the derivative, you get y triple prime. But here's y triple prime. Does everybody see that's the y triple prime? So if that's the y triple prime, take all of this and move it over to this side. So we're going to have minus y prime minus e to the t y squared cosine 3t. But all of this is scratch because you're not supposed to have y's because we're switching over to x's. So instead of this, how do you write that in terms of an x? Use your dictionary.
Minus y x2 minus e to the t
What's this? What's this one?
minus y x2.
No. You can only have x's. You can
Minus
only have-
x1, x2.
Yes. It's x1, x2. So you were right halfway. Now, minus e to the t, and what about this one?
X1 squared.
Exactly. And then over here, you write cosine 3t. Okay? And you can't have this, okay? Everything has to be in terms of the x's. So this is just scratch. So then eventually after you finish this, you can delete it, okay? Or erase it. And make sure you only leave it in terms of this. So does everybody see now that you've actually finally rewritten this as dx dt? And on the right-hand side, you have a function like this. So now, so this is the dictionary. Let me just move the dictionary now down here. So on this side, so you all know that this, what is x of 0 going to be? What is x of 0 going to be? Well, x1 is y, and what is y of 0?
2.
2.
Yeah, so you're going to write 2, -1, 5. Okay, so I'll go ahead and grab this. I'll put him right here. So let's see. Okay, so it's hard. Let me just move the dictionary out of the way. Move this over here. You're like this, right? And then over here, what you can write is you can go, let's see. You can go, well, you know, this is probably just the best thing, but you can go x of, let's see, how should you do this? You can go, you write, you would go x of 0, x1 of 0, right? x2 of 0, x3 of 0. Oh, you know what? This is how we would do it. And then this would be the 2, -1, and 5. Okay, but write it as an initial vector. Okay, so let's go ahead and do this one. So let's say we have a higher order system. I'm going to give you a second order system. Okay, so this is a system, and it's going to be Q1 double prime. And I don't know, but you're going to combine the Q1, Q2, some function of Q1, Q2, and Q2 double prime, and just combine Q1, Q2 in some function. So here's a second order system. So whenever you have a higher order system, you can always make it into, recast it into a first order system. So create a dictionary and think about what dimension it's going to be. Create a dictionary, think about what dimension it's going to be, and then we'll work together and figure out what it is, okay? So think about what it should be. Okay. So let's do a dictionary on the side. And looking at this, does everybody see that it would be something like this? X. By the way, remember, every time you see this, right, this is actually an x of t. Right. And then this is an of t. This is an of t. This is an of t, right? But I don't necessarily write it down. Okay, similarly here. So here, can everybody see you're going to have an x1, x2, x3, x4? And then what you're going to have is you're going to have a q1, a q2, q1 prime, q2 prime. Okay? So then you would have, and write down all your first derivatives. Derivative of x1, derivative of x2, derivative of x3, and then derivative of x4. Go like this. It's always good to write them down first because people usually just like to go line by line and then they get exhausted and they forget everything. Okay, what is the derivative of x1 if you go ahead and look at your dictionary? So here's your x1. What's the first derivative?
Q1 prime.
Exactly, but you have to write in terms of x's, so what is it?
X3.
Exactly, it's x3, right? So you write down x3. Next, derivative of x2. So go over here, look at your x2. When you take the derivative, what is that equal to in terms of x's?
X4.
Exactly, right? You write down x4. Next, let's go up here. Derivative of x3. What is the derivative of x3?
Q double prime.
Q1 double prime. And Q1 double prime is right here. So Q1 double prime is right there. And so what you do is you take this and you move it over to that side. And so does everybody see that that is going to be negative F1 of what, and it's going to be some combination of Q1, Q2. But we can't write down Q1, Q2 because we need it all in terms of x's. So does everybody see, what would I write down instead? It's x1, x2, right? Because that's the Q1, Q2. Okay, so you're going to sub it in here and you move this whole thing over to the side. All right, let's do that again. What is the derivative of x4? So here's x4. What's the derivative of x4?
Q2 double prime.
Right. And then you would take this, move it over to this side, but you're not allowed to have q's. So you use your dictionary and write it in terms of x's. And so does everybody see now you have minus F2? So you're going to have Q1, Q2, but that's actually X1, X2, right? And now, does everybody see that we now have, that was a system. So this is a higher order system. And we recast it into a first order system. And now tell me, what is the dimension? What's the dimension?
4.
4. Okay. So now you will be able to do a lot of quiz 8. Let's do the next half. Okay, so here we have this is our basic setup. All right, and what we want to do now is we want to do tank problems. So what we're going to do is we're going to have tank problems. And remember how they work. So Q of T is a quantity in the tank at time T. People in the world, solute in a lake, pollutants in a lake, money in a bank, or however much you owe. All right. But what we're going to do now is we're going to use the principle that we had in the past. Remember what this was? This was rate in minus rate out. And now we're going to have several quantities. And what it's going to be is for each quantity, it'll be rate in minus rate out for that tank. So tank I, and this is tank, right, rate out. This is going to be tank I. We have several tanks, okay? So go ahead now, and we can go ahead and just look at our handout. So grab this handout with, oops, I think you guys have all this. You have this one, right? If you don't, I'm going to read it to you, and we need to practice drawing it anyways, okay? So suppose you have tank A. It contains 50 gallons of water, in which 25 pounds is dissolved. Suppose tank 8 contains 50 gallons of pure water. Liquid is pumped into and out of the tank as indicated, and the mixture is exchanged between the two tanks. Assume the liquids are well stirred. Describe a system by a system of differential equations. So for this, we're going to say, so let's let S1 of T be amount of salt in tank A at time T. And S2 be the amount of salt in tank B at time T. And what you should do is look for the units, because the units really helps you. So you should write pounds of salt. So the goal is then to find the amount of salt at any moment in time. So let's draw this again. So this kind of helps us see everything, okay? So we have tank A. we have tank B. And so we have pure water coming in at 3 gallons per minute. If it's pure water, remember that's 0 pounds of salt per gallon. That's the concentration, right? Then it's going to come out and it's going to go over here and it's going in there or leaving it 4 gallons per minute. And then whatever you have here, it's coming back and that's 1 gallon per minute. And now you're going to go ahead and say it's going out over here also 3 gallons per minute. Okay, so again, you have S1 and S2. So what you should do is write out the first derivatives. Again, I'm just telling you, write the first derivatives down first because everybody just does that and then they get exhausted and they forget about the rest of it. So you want to write the system. Next, go ahead and notice the top is salt in pounds and the time is in minutes. This will help you because you want to go pounds per minute. So that will help you. Okay. Then the principle is always rate in minus rate out, right? All right. So we're going to look at tank A. So remember, this is going to be the salt at any moment in time, the pounds of salt, and this is the pounds of salt there at any moment in time. So let's take a look at this. If you have pure water coming in at 3 gallons per minute, pure water is 0 pounds of salt per gallon. So it's always concentration times the flow rate, right? So it's 0 pounds per gallon coming in at 3 gallons per minute. And you can see gallon and gallon cancels. And basically 0 times 3, no salt is coming in. So that's this situation there. Then what's happening is you need to look at what's going to happen here. Let's say you're going to flow out here. So, oh, look at this. We have more stuff coming in. So you know what? Let me just go ahead and let's do this. So we have stuff. This is still rate in. We're working on rate in. Okay. So here, what we have is the flow rate, 1 gallon per minute. But we need to know what is the concentration. So we have to go over here and look at the concentration of salt. So going back to this, it said in tank B contains 50 gallons initially of pure water, 50 gallons. Okay. So looking at this, you have 1 gallon per minute going out, 1 gallon per minute going out, and 4 gallons per minute coming in. So does everybody see if you have 1 gallon per minute going out, 3 gallons per minute going out, that's 4 gallons per minute going out, 4 gallons per minute coming in. So at any moment in time, what's the volume? What's the volume?
It's unchanged.
It's unchanged. It's going to stay at 50 gallons. And so remember what concentration is. It is mass divided by volume, right? So this is the amount of salt. So we have S2 pounds per 50 gallons. That's the concentration over here. And then it's going to flow into tank A at 1 gallon per minute. So does everybody see? The concentration over here is mass divided by volume. And this is the amount of salt, and it's going to stay at 50 gallons. Okay? So this is all rate in flowing into tank A. Now let's go ahead and do rate out. Okay? So that's this. So let's go ahead and we're going to subtract. So does everybody see this is where we subtract this? Okay. And so let me move this over here. Okay. So let's go ahead and look at this. So notice now we need to figure out the concentration over here because it's going to go this way. So the concentration is going to be, well, mass divided by volume. This is the mass, S1 pounds of salt. What is the volume? Let's go back up here. And it says tank A, suppose tank A contains 50 gallons of water. Okay, so it has 50 gallons. You have 3 gallons per minute coming in, 1 gallon per minute coming in. That's 4 gallons per minute coming in, and 4 gallons per minute going out. So what is going to be the volume at any moment in time in tank A? If you start with 50, it's going to stay at 50, right? Because you have 3 coming in, 1 coming in, and 4 going out per minute. So it'll stay at 50. So what's going to happen is the concentration in tank A is S1 pounds per 50 gallons. And it's going to flow out at 4 gallons per minute. Everybody see? And so there you go, rate in minus rate out. And notice that gallons and gallons cancel and you get pounds per minute. Now, focus your eyes. So that was all working on tank A. So that was tank A. Now we're going to do tank B. Right? So tank B, we do rate in. So rate in, can you see that going out, the pink going out of A is actually the same thing going into B. So again, you notice the concentration here is S1 pounds per 50 gallons. It's flowing in at 4 gallons per minute. So all you have to do is you can just take this and just move it over here. Or you can rewrite it again just to double check. But that is always going to be the same. So that is flowing in to tank B. But now you want to write down what's flowing out. Notice it's this that's flowing out. And can everybody see that that is that dark blue? And the dark blue is S2 pounds per 50 gallons because it stays the same, flowing out at 1 gallon per minute. So do you see it was going in to tank A, but now you subtract it because it's now flowing out of tank B. The last now is we should do this, right? So let's go ahead and do this. So that's a flowing out. So make sure you have plus and minus correct. So this is flowing out. Okay. So this is rate out. So again, you look over here, mass, pounds, S2 per 50 gallons, flowing out at 3 gallons per minute. That's the green. And so there we go. And everybody can see gallons and gallons cancel, you have pounds per minute. When you write the answer though, do not just leave it like that. You have to clean it up. So this is 0. And then over here, you have 1 over 50 S2 minus 4 over 50, which is 2 over 25 S1. Then over here, you have ds2 dt. So that is 4 over 50 right here is 2 over 25 S1. And this is 1 over 50, 3 over 50, so minus 4 over 50, so it's actually minus 2 over 25, S2. So you need to combine this, because this is S2 and that's an S2 as well. So combine them. So then you have this, and now what you should do is you should write it in the correct order. So notice you should write the S1 first, and then you should have the S2. So write it in the correct order. Okay, so this, go ahead and write it S1, S2, right? And now, last thing, it had 50 gallons of water in which 25 pounds of salt is dissolved. So you can see that over here, what you had was at time 0, S1 of 0 was 50 pounds of salt. And over here, tank B has 50 gallons of pure water. So that's S2. So that's no salt. Okay. So now you'll go ahead and you write S1 of 0 is 50. Did I say 50? Yeah, 50. Leave off the word pounds. S2 of 0 equals 0. And this is your system. Notice it's linear. And if it's linear, then what you can do is you can write it like this. D dt, and then you would say S, right? And you know what the S is? The S is going to be S1 and S2, right? But remember, whenever you have dependent variable, remember dependent variable is really a function, right? It's actually this, right? Because this is going to be changing as time changes, right? So this is dependent on time, the amount of salt that is, right? And then over here, what you have is does everybody see? You have minus 2 over 25, 1 over 50, 2 over 25, minus 2 over 25, right? And does everybody see? You're going to have, now notice this, you're going to
Professor,
have S1 and S2.
Professor,
Yes.
S2, is it not S2 or 50 is equal to 0 or
What? No,
S2?
because this. Uh,
Like the initial value for S2.
S2 is 0, right? S2 is 0 because there's no salt. Tank B contains 50 gallons of pure water. So
And
that's
Is
this.
it not S2 50 is equal to 0?
No.
Okay.
We're talking about salt, not water. Gallons is the volume. It's the water, right? We're talking about this, no salt. This is no salt, okay? Careful. Don't get the volume and the salt confused. All right. So you can so let me write it out this way first. Okay. So that you can see this first. Okay. So actually, let me not write it. I'll go S1, S2. Okay. Like this. And then, okay. So now, this is,
Professor, would S1 of 0 be 25 because it says 25 pounds of salt initially?
oh, I'm sorry. You're right. 25 pounds. You're right. 25. I just told you not to do that. 25 pounds of salt. Exactly. So S1 of 0 is 25. S2 of 0 is 0. And lastly, when you write this all out, okay, let me go ahead kind of one last time. So when you do this, the other way to write it is let me write it like this, d dt of S equal. Now you do have to write this out. There's no way to, you have to write this. And then you can write it like this. And then here you go S of 0, and then you say like this, and then you go 25, 0. There you go. Okay. So everybody see how you write this down? All right. So let's do another one real quick. Okay. But before we do this, I just want to say something. What if I change the problem a little bit? What if I change the problem a little bit? So let's say that we had only 2 gallons coming in. All right. and 4 gallons going out. So that's 6. Okay, that's a good one. Okay, and then you know what? I'm going to change this. So 2 coming in, and I'm going to say 5 flowing out. I'm going to change this. 5 flowing out. Okay. So how would you have changed this? So going back to this now, does everybody see that the blue over here, this would have been 2, let's see, 0 pounds, and then you would have times 2 gallons per minute coming in. So that would still be 0 like that. But over here at S2, think about this. You would no longer have 50, because if you had 50 and you had 3 gallons per minute going out and 5 gallons per minute, I'm sorry, 2 plus 1 coming in, so that's 3 gallons per minute coming in, 5 gallons per minute going out. How much are you losing every minute? How much are you losing every minute?
2 gallons.
2 gallons. So you would have, instead, your concentration is going to be, so for your pink right here, your pink concentration is going to be over here. And your pink concentration is you're losing 2 gallons every minute. So do you see it's like this? So this is your pink concentration. So when you do your pink concentration, you're flowing out, right? It's 50, so it's S1 over 50 gallons minus 2 gallons per minute. So it's going to be minus 2T gallons. So that's your volume. Now for your blue, let's take a look over here. So over here, you have 1 gallon per minute going out, 4 gallons per minute going out, and 5 coming in. Are you gaining or are you losing?
Gaining.
Gaining. And how much are you gaining per minute?
1.
1 gallon. So you're going to gain 1 gallon per minute. So you're going to have 50 plus 1 gallon per minute. So times the amount of time. This is what's going to happen. So after 1 minute, it's 51 gallons. After 2 minutes, it's 52. After 3 minutes, it's 53. Okay. So does everybody see? This is what your new blue would be. That's your new concentration. Okay. So in exactly the same way, then you have to update this. And then here, again, this is going to be, this is this. Okay. And so this is going to cancel with this guy. So this is this. And then over here, you're going to have to update this. And this is going to be plus 1T gallons. Okay, so this would be your new blue. And then your this one over here, the green, remember that's ST, so that's, you're right here. Oops. You're right here. Right? So S2 pounds, and you're actually gaining 1 gallon per minute. So there we go. So this is the green. That's the concentration. Okay. So this is how you update it. And I do lots and lots of examples in Quiz Study Guide 8. So let's do another one. Okay. Let's do this one. So here we have 3 large tanks, and they're working like this, right? So I'll draw it again for you. So you have this, tank 1, and you have pure water coming in, 4 gallons per minute. Then you have tank 2 or tank, B, and then you have water being pumped this way, 4 gallons per minute. And then you have the third tank, and you're just pumping water in. that's going at 4 gallons per minute. And then you're going to have 4 gallons per minute. Okay. All right. So you're going to have S1, S2, S3, and it's going to be the amount of salt in tank A, time T. Okay. And this is going to be the amount of salt in tank B at time T, amount of salt, tank C, and we'll say pounds. Okay. So then what you want to do is you're going to look at tank A, tank B, tank C, right? So you're going to say ds1 dt and write down your first derivative and write them all down, because otherwise you can see how long the process was and you might get tired. Okay. So it's always going to be rate in minus rate out. So rate in, let's take a look. So right here, you have pure water coming in. Pure water means 0 pounds of salt per gallon. And you do concentration, 0 pounds per gallon, times 4 gallon per minute. So does everybody see 0 times 4? That's going to be no salt is coming in for the blue. Then going out, can everybody see that you have this, right? So that's going to be this. Now, if you have 4 gallons per minute coming in, so this is S1 of T, and this is the amount of salt to S2 of T, S3 of T. So if you have 4 gallons per minute coming in, 4 gallons per minute going out, over here, let me ask you, and you start with 200 gallons, at any given moment in time, how many gallons do you have?
200.
200. So you're going to have concentration, S1 pounds per 200 gallons, times 4 gallons per minute. And this is what it's flowing out. And now, can everybody see the same thing? You're going to have this, but now it's flowing in to S2. So that's the rate in, right? And now you can say, hey, what's this? Okay, so now we're going to flow out. So that's S2, so this is going to flow out, right? So over here, you have S2 pounds per, and now, let me ask you, if you have 4 gallons per minute coming in, 4 gallons per minute going out, how many gallons do you have at any given time when this is the number that you start with?
150.
150. So that's going to be 150 gallons. And it's flowing out at 4 gallons per minute. And you can see the gallons and gallons all cancel. And you have pounds per minute, right? This is pounds. This is minute. So you want it all to match, right? So all of these are going to be pounds per minute. Okay. Okay, so now we're going to look at tank 3, but look, the flow out from tank 2 is actually the flow in for tank 3. And now over here, let's go ahead and let's look at this. Oops. Let's look at this. Okay. Wow, that purple isn't so clear. Well, okay. Maybe this dark blue. Okay, so there we go. So we're going to do that. So notice that that's flow out. So that's minus. And it's flowing out from S3. It's flowing out here, tank 3. So the concentration is that much. You flow in 4 gallons, flow out 4 gallons per minute. And you start with 100 gallons. So how much, what's the volume going to be at any moment in time?
100.
So it's 100 gallons. S3 pounds per 100 gallons. The flow out is 4 gallons per minute. Look, the gallons and the gallons cancel. You get pounds per minute. Okay. And then I have to ask you guys, please always, get rid of the units and make it look nice and go like this: ds1 dt, ds2 dt, ds3 dt. And then the first one, the green, that's 4 over 200. So that's 1 over 50. S1, that was a negative. And then that's 1 over 50. S1, so that's the green. And then minus 4 over 150, so that's 2 over 75. S2. And then that's 2 over 75. S2. And then the purple is minus 1 over 25, S3. However, let's make it all look nice. So you can go over here, put this over here, right? And notice that you have 0 S2, 0 S3, 0 S3, 0 S1. And does everybody now see that you have the derivative of S, and it's going to be minus 1 over 50, 0, 0, 1 over 50, minus 2 over 75, 0, 0, 2 over 75, minus 1 over 25, S, right? And remember who the S really is. I could write it just like that, or if you wanted to put more detail, right, you can see it's like this, right? So you could also, if you wanted to, you could write it like this. It's nice to go ahead, though. Right, this is your S1, this is your S2, this is your S3. So this is you putting it into matrix form because it's linear, right? So make sure you put these in order because it has to be S1, S2, S3. Okay. So real quick, what if I had made this 5, a flow out of 5, right? And 5 coming in, 4 coming out, and then how about this is 3? Okay. Does everybody see, like with the green, right? We would have to change the green. And if you are flowing in 4 gallons per minute and then flowing out at 5 gallons per minute, how much are you losing per minute?
1 gallon.
Right. Does everybody see then the green? You would have to change it minus 1 gallon per minute, so minus 1 T, and then here's the gallons. And the gallon and gallon cancel right here. So this is your green, okay? And so then over here, of course, you would have to change that as well. So this is over here. You would have to do minus 1 T gallons. This gallon and this gallon cancel, and this is your green. And then with your pink, notice that you have 5 gallons per minute coming in, 4 gallons per minute going out. So how much are you gaining per minute?
1 gallon.
1 gallon. Okay, so when you're doing your pink, right, you have 150 gallons there, but now you're gaining 1 gallon per minute, so plus 1 T per gallon. So 150, so after a time and after a minute you have 151, after 2 minutes 152, 3 minutes 153, right? So this is your pink. Okay, and once you change that, of course, you have to change this, same thing. So this becomes plus 1 T, right? Gallon. And this gallon cancel. So, and then finally, looking at the third tank, if you have 4 gallons per minute coming in, 3 gallons per minute going out, how much are you gaining or losing?
You're gaining 1 as well.
You're also gaining 1. So this is 1 T gallon. Okay. So this and this cancel, and that's going to be your purple. So I just want to say, you know, usually it's not going to balance, you know, because we want you to know how to do that kind of problem. So Quiz Study Guide 8 has a lot of detail. So practice those. And when you finish doing everything, of course, get rid of all the units. So you use the units to make sure that you do it correctly and set it up well, and then get rid of the units. And then, you know, then you can write it this way. Okay. And there we are. Thank you all. And we are in good shape, and we're going to be ready to start the next section next time. So today is Wednesday. Let me double check. I'm going to stop the recording.